Hi.
Let me make sure.
Yep,
I think we are recording. Okay, so this is the review after the review, right? For chapter 9. Chapter 9 review. Okay, things that you will need to know. You will need to know how to find coterminal angles. Okay, do you know what it means to be a coterminal angle? They're in the same spot. Okay, they're in the same spot. So like 20 degrees is the same thing as 380 degrees, or that's the same thing as negative 340 degrees. Does that make sense?
Yeah.
Now, if I ask specifically for the one that has these requirements, which one are you going to do? If I ask specifically for these requirements, that my angle has to be between 0 and 360, is what that says. Which one are you going to give me?
One that's between that.
One that's between that, which is which one up there?
Probably
20.
20. Yeah.
So specifically, you're going to give me 20, okay? Because there are an infinite number of coterminal angles. So I will ask you specifically for the one that's in this interval, okay? Now, what if I say I want the coterminal angle for 15 pi over 4? 15 pi over 4. I want specifically the one 15 pi over 4. How do I get him down? Minus 2 pi, sure. So if we subtract 2 pi, I want to find a common denominator, so that will be, what, 8 pi over 4? Mm-hmm. So he will be 7 pi over 4. Okay. Do I need to subtract again? Or is 7 pi over 4 going to do it for me? 7 pi over 4 is, if I would subtract another 8 pi over 4, now it would be negative. So I want to stop there at 7 pi over 4. Does that make sense?
Yeah.
Okay. All right, so those are coterminal angles. Now these ones are going to be the ones that get you. These ones are like arc length.
Is this still with coterminal?
Nope, this is a different category. Arc length. So let's say I have a circle, and the radius is 5, and the angle is 120 degrees. What is the length of that right there? Shut it off. Shut it off. Because I told you to, and I am your teacher, and you listen to me. Arc length, right there. I want to know how long that is from there to there. Okay, so let's say I would ask you to find the entire length all the way around. What's that called? The circumference. I'm asking you to find the circumference, but I'm only asking you to find part of the circumference. So if I asked you to find the entire circumference, you would do 2 pi r, right?
Yeah.
So the radius is 5, so this would be 2 times 5, or 10 pi. 10 pi would be all the way around the circle.
10 pi times 1/3.
But I'm only asking for 120 degrees out of it. So I take it times 120 out of 360, which is 1/3, right, if you want to reduce. Or you can just do 120 over 360.
Hold on, wait.
Does that make sense? Confusing?
Because
Okay.
you just want that part.
I only want that fraction of the circle. So I only want 100 degrees out of 360. So what does that come out to be? You take 10 pi times 120 over 360. It's going to be something weird. It's going to be a decimal. Let's say this is in inches. 10.47. That sounds about right. 10.47 inches is what that will be. Okay?
Do we have to change like any time between radians and degrees?
Yes. Yes.
Okay,
We'll do that one next.
What should that be in? Does it matter?
This is a length, so it's not radians, degrees,
So
or
it
anything.
doesn't matter.
No,
Right.
no.
Will you
Okay.
tell us when?
So let's do radians versus degrees. We'll do that next. Radians versus degrees. Okay, so let's say I have 54 degrees. We'll do something nicer. Let's do a nicer degree. Let's do we'll do a negative, so that you know what to do when you're doing a negative. Negative 380 degrees. Okay, I want to convert that to radians. So radians. Okay, so we're going to put it over 1, right? And to do this, you do either pi over 180 or 180 over pi. This is like your cheat sheet right here. pi over 180 or 180 over pi, you want to put, which one did you say? Pi over 180, because you want the degrees to cancel. So these degrees cancel with these degrees. And then I just reduce, so I'm going to knock the zeros. And 38 and 18, if I reduce those two, I can divide by 2, I think is all that it will do. Do you know what 38 divided by 2 is?
19.
19. So this would be negative 19. You just keep the negative. And 18 divided by 2 is 9. So what will that look like in radians?
19 pi.
Negative 19 pi over 9. That's how you'll leave it. So kind of gross, but that's what it is in radians. Okay, now if we're going degrees, let's say I have 17 pi over 6, and I want to convert that to degrees. Now what do you multiply by?
Pi over 180. No, 180 over pi.
180 over pi, because I want the pi's to cancel. Pi, pi. So anything else that will reduce?
6 and 180.
6 and 180. So this will become 1 and 30. Okay, then I take 30 times 17, which would be 510 degrees. Is that right?
Yeah.
There you go. That's how many degrees it is. So radians versus degrees, that's conversion between the two.
So does it still matter where
No. The only time you have to worry about the mode that your calculator is in. I'm gonna maybe put a little thing here. Worry about mode of your calculator when doing sine, cosine, tangent of things. That's the only time you have to worry about the mode of your calculator, is when you're doing sine, cosine, and tangent. What? Well, you could, except you're going to be talking into it. No, don't do that. I'll give you a calculator. No, let's go to that one right there.
There's no thing on it. It's not comfortable.
We don't care. Okay, so that's the only time you have to worry about what mode your calculator's in.
Look how
Sine,
easy
cosine,
this is.
tangent. Okay,
Look how easy this is.
are we good?
See this?
Good that far? No, I don't think so.
You can tell when I'm cheating.
All right. Let's say that I do. This is basic right triangle trig. So right triangle trig. These are fair game. Let's say I have a right triangle, and I say that this is 6, this is 9. Find this angle. Or I do another triangle where I say this angle is 31 degrees. This is 7. What's this guy? Okay, so these are going to be two different types of problems. So let's deal with the left one first. How are you going to set that one up? You have your angle theta. 6 and 9. 6 and 9 is adjacent hypotenuse. So cosine. Cosine of angle theta is 6 over 9. Yeah? And then what? Take the inverse. Inverse cosine. Whenever you're trying to solve for an angle, you take the inverse. So inverse cosine of 6 over 9. You can reduce the 6 over 9 if you'd like. It doesn't matter. Inverse cosine 6 over 9 or 2 over 3. This time it will matter whether you're in degrees and radians. Which one do you want to be in this case? It depends on whether you want your answer to come out as degrees or radians, right? So in this case, if you want to do degrees, I got 48.2 degrees. Okay, that's what that guy is. Okay, if I say I want my answer in radians, you'll just put it into radians. Okay. Now, this one, you definitely have to have it in one versus the other. Which one do you have to have it in for this one? Look at what you're given. You're given 31 degrees, so this one has to be degrees. This one you were solving for the angle, so I can represent my angle as either radians or degrees, it doesn't matter. This one has to be degrees because I give you 31 degrees. So 7 is opposite. The question mark, we'll call it x as the hypotenuse, so we're going to use what, sine? Sine of 31 equals 7 over x. Okay, now how do I solve for x? I solve for x.
Or divide, no, multiply x.
We're gonna switch them. Okay, 7 divided by sine 31. And I have 13.6. Yeah?
Yeah.
Something like that? Okay. Does that make sense? Now, an unreasonable answer. What would be an unreasonable answer in this case? For this problem, if I'm solving for x, what would be not reasonable? Anything less than 7, right? Because it has to be bigger than 7. Okay, so yes, you were right. Okay, other things, let's say, okay, let's talk about graphing trig functions. Graphing. So I'm going to do y equals a sine bx minus c plus d. And we'll write out what each one of these things are. And then I'll give you an example. Okay. Now this could also be cosine. So we could do sine or cosine. Yep. Sine or cosine. Okay. These numbers, let me actually put values in there. So let's say I have, we'll do a negative. -3 sine of 2x minus pi plus 4. Okay, and let's fill in A, B, C, D. This could be sine or cosine. Okay, so A, B, C, D. What's the A value going to be? A value is -3, and that tells me really two things. The first thing it tells me is the amplitude is what?
Down 3.
No, that's shifting it up and down. Amplitude means it's just 3. It's going to be like 3 tall and 3 low. Does that make sense?
Yeah.
But what's the negative tell you? Reflected. So I'm going to put a little star there. Kaden. B. What's the B value? 2. What does that 2 help me find? Period. Okay. And to do the period, I have to take 2 pi and divide by B, which is 2 pi over 2. So my new period now is pi. I'm going to put a little star by period because if it's tangent or cotangent, what's the period?
So
Period is pi instead of 2 pi. So you would do pi over b instead of 2 pi over b. Is this all kind of ringing a bell?
Hold on.
Sure.
So if the period is pi, is that b pi then? Is b just pi then?
No, b was 2.
Okay.
So this is, by converting them from the ABCD to this stuff over here, this is how you graph it, right? You want to take it from ABCD to over to here so that you know how to graph the thing. So we're just taking the numbers and figuring out what we have to do to graph. C, what's the C value? -pi, okay? And what does that help us find? The phase shift. Okay, so to do phase shift, we take -c and divide by b. So in this case, it would be negative pi over b was 2. So pi over 2, that means I'm going right pi over 2. That's what that guy means. Okay. And D, what's the D in this case? 4, okay. And what does that tell you? The vertical shift, and it's what in this case? 4 up, okay. I probably will not give you a problem that has all 4 of those numbers at the same time, but I'm just trying to give you an example that's got all 4. So this is as hard as it will get, but I don't think I give you all 4 of them at the same time. I definitely don't make you graph it if it has all 4 of them at the same time.
I thought that if it was negative, it was right, and if it was positive, it was
So after you take it out of the equation, So looking at the equation right now, this is negative. That
Oh,
means
we're
it's going
seeing
right.
it to the wrong.
So after
Okay.
you take it out of the equation and do the negative c over b, it's positive, which means it's right. But actually looking into the equation, it's the negative. It's the opposite of what it is up there. Yes. Okay? All right, so that's graphing. So I'll ask you, like, here's your equation. What's the period of this equation? And you'll find the period. Okay? Or I'll say, graph this guy. Okay? I won't make you graph one that has all four of them at the same time, but that's what that's going to do. Okay? Let's say I say find cotangent. This is,
Is this another example?
no, this is not another example. I don't know what heading I want to put on this.
So this.
Let's do inverse functions. Inverse functions. Let's say I want you to find cotangent of arc cosine of 5 over 13. Okay, you had a bunch of these on your review. And one that was really ugly that had like X's and such in it.
We
Okay.
did.
So arc cosine, this guy just means inverse cosine. Okay, so that means cosine of something is 5 over 13. Let's draw a picture of what he looks like. What quadrant are you going to put that in? What quadrant are you going to put the triangle in? In 1. 5 over 13 is a positive 5 over 13. Inverse cosine lives here, and it also lives here. But cosine is positive in the first quadrant, so you're going to draw him in the first quadrant. Yeah? Okay? And then I'm going to label my sides. So cosine is adjacent over hypotenuse. So the adjacent side is 5, the hypotenuse side is 13. What's the other side? What's the other side going to be? 12. You can do the Pythagorean theorem if you want to. That guy will just be 12. Okay? So this inside piece right here tells me what it looks like. It looks like this. But now I want to find cotangent of that. Okay? So cotangent of that, tangent is opposite over adjacent, so I want to flip that and do adjacent over opposite. So what's my adjacent over opposite going to be?
5 over 12.
Yep, you betcha. 5 over 12. So those are inverse functions. Let me see what else I have for inverse functions. I don't know. That might be it for inverse functions. Let's talk about reciprocal functions. Reciprocal functions. Let's say I have cotangent of 47 degrees. How do I figure out what cotangent of 47 degrees is? Because I don't have a cotangent button in my calculator. You're close. You're close. It's not, okay, so it's not tangent of 1 over 47.
Inverse tangent.
No, cotangent is not the same thing as inverse tangent. But Lacey was close when she said tangent of 1 over 47.
Huh, I do too.
It's almost. You have a cotangent button on your calculator?
Yeah.
You're
Is the answer
goofy.
0.93?
I have no idea. I don't know what the answer is. How do you do it? It's Lacey was close. It's not tangent of 1 over 47.
I have no more brain cells left today.
You're close. You were close before.
Can you give me another? Isn't that 1 over sine looking thing? 1 over sine? Yeah, 1 over.
It's 1 over tangent of 47. So you don't do 1 over 47. It's 1 over tangent of 47. Does that make sense? Yeah, you flip that. Okay, so do I want to be in radians or degrees?
Oh, I don't know. Radians. I don't know. Radians. Degrees. It's degrees. Because you have a degree.
You want to be in degrees.
Okay.
1 over tangent of 47. What's that come out to be?
0.93. That's what I got.
Are you sure?
I will do it your way too.
Do it my way too. I just want to make sure that you're using the right button. 1 divided by tangent.
It's the same answer.
Is it?
Great.
Woo!
Yes.
0.933.
I have a. Oh, I like this guy.
There you go. You cheater. Cheater Peter. Okay. What else do I want to say? Let's say I give you the point. I'm picking really nice numbers. Let's say I pick the point. This is random. This is a random fact. Let's say I pick the point. I say find 6 trig functions of angle that goes through -3, -4. How do you do that?
Hold on. So you write out your things.
You write out what things?
Your sine, cosine, right?
Oh, sure. Sine, cosine, tangent, cosecant, secant, cotangent. And we really have to put like our thetas in there. Theta, 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 theta.
Well, you can't have wrong with you doing it.
No, but make me happy and do.
Yeah.
Okay. So where do I begin? What? Okay. And it's in the third quadrant. See, she is golden. Okay. And let's label my triangle. -3, -4. -3, -4. What's the hypotenuse side? Is it -5 or +5? The hypotenuse is never negative. It's always positive. Okay. And then you do sine, cosine, and tangent from that, right? So here's my theta. Opposite over hypotenuse, -4/5. Cosine adjacent over hypotenuse, -3/5. Tangent opposite over adjacent. -4 over -3, which is +4/3. Okay, then just flip everything. So -5/4, -5/3, +3/4. Good? Okay, what if I say, what do I want to say? Tangent of angle theta equals negative, -3/4, and cosine is less than, well, we'll do sine is greater than 0. Sine is greater than 0. What the heck does that mean? And I say find cosecant. I don't know. What the heck does that even mean?
So this would be just opposite of sine.
Uh-huh.
So you have to draw your triangle.
Sure. Draw a triangle.
Well,
Okay.
it's right there.
What
It's
quadrant are we in?
Is that the same triangle?
I don't know. Maybe.
So opposite.
Okay. What quadrant are we in though?
It's not the same. 2.
How do you know we're in 2? The information up there tells you what quadrant you're in. So let's talk about tangent. Tangent.
Is this like a connected problem or is it?
No, it's not the same. It's not the connected problem. I'm just using the same numbers again. Because 3 and 4 are nice numbers. So tangent is -3/4. Okay, so really I have to think about, okay, so tangent is -3/4. I could have the 3 be negative and the 4 be positive, or I could have the 3 be positive and the 4 be negative. So I have to decide which one it is, right? So what quadrant is tangent negative in? What 2 quadrants is tangent negative in? What? What 2 quadrants is tangent negative in?
Is it the third and the first?
Tangent is sine over cosine. So in the first quadrant, sine and cosine are both positive. And in the third quadrant, sine and cosine are both negative. So positive over positive and negative over negative make
Isn't it
a
2 and
positive.
4?
It would be 2 and 4. So we're looking at either this quadrant or this quadrant. Okay? Sine is the x or y. Which one is sine?
Y.
Sine is the y, and I want the y to be greater than 0. So which quadrant am I looking at now? 2. I'm only looking at 2 because that's the only quadrant where sine is positive or it's greater than 0. Now you can draw what your thing looks like. So the opposite and adjacent, the opposite side is 3, the adjacent side is 4. Which one of those is negative? The 3 or the 4? The 4 has to be negative. And what's the hypotenuse?
5.
5, always positive. So I want cosecant.
So you do sine and you
Sine is opposite over hypotenuse. So I want hypotenuse over opposite, which is 5 over 3. Okay? So do you see how you use those pieces of information to tell you what quadrant you're in?
Mm-hmm.
Yeah? Okay. Let's see what else I want to do. Really, that'll get you pretty good, actually.
Very funny. I like calc a lot more than stats.
So
Yeah? Really?
Yeah.
Nice. Oh, let's talk about complementary versus supplementary. Complementary versus supplementary. Complementary versus supplementary. Okay, so let's say I have 25 degrees. What's complementary to 25 degrees? What's the complement of 65? Is it 65? I believe so.
Yes.
Okay, what's the supplement of 25?
We had a meeting about
Okay, complement, they have to add up to be 90. They have to add up to be 90 degrees. Okay, supplement, they have to add up to be 180. So, if 25 degrees is what I have, what will I have to add to it to be 180? 155? Is that right? Yeah, I believe you're right. Now, a little harder. Let's say I have pi over 7. What's the complement and the supplement of pi over 7? Okay, so
5 pi over 7
what?
Right?
What are you talking about?
You said the complement and supplement.
Yeah.
So 3.5 pi over 7 would be pi over 2. And 6 pi over 7 would be pi.
Isn't it just plus?
Yep.
That one's
Not
plus
wrong.
pi, isn't
Okay,
it?
so
that one's
what
plus
you're trying to
pi.
so 90 degrees is how much? In
Pi
radians.
Pi.
Pi over 2. Okay, 180 is just pi. So basically, the way that I set this up, if you don't want to have to think about it, I want to be able to add something to pi over 7 to get pi over 2, right? So if I'm trying to figure out what this guy is right here, I can subtract pi over 7 minus pi over 7. So I want to take, just wait a minute. I want to take pi over 2 and subtract pi over 7 from it. Now I have to find a common denominator. 14. So how many pi's over 2 is 14?
7.
So this is 7 pi over 14
2.
minus 2 pi over 14.
Yes. 5 pi over 14.
So this guy's 5 pi over 14.
Wow.
To check my answer, let's see. Pi over 7 plus 5 pi over 14 should add up to be pi over 2, right?
Yeah.
Those two should add up to be 90 degrees. Pi over 7 is like 2 pi's over 14. Does 2 pi over 14 plus 5 pi over 14 make
Yep.
7 pi over 14 or pi over 2?
Mm-hmm.
Yeah?
Yeah.
Okay. Now, same thing here. Pi over 7 plus something has to add up to be what? If I want
Pi.
supplementary. Pi. Okay? So I'm going to subtract pi over 7. Subtract pi over 7. So I need pi minus pi over 7.
Over 7. Then
So I'm going to
7
make
pi
this
over 7.
I'm going to make this 7 pi over 7 minus pi over 7, which is
6 pi over 7.
6 pi over 7. So then if I want to check myself, pi over 7 plus 6 pi over 7, does that make pi?
Yeah, 7 pi over 7.
It'd be 7 pi over 7, which is just
Yes.
pi. Okay? That was really a lot of pi's going on.
Wait, so is your answer?
Was that confusing?
Wait, is your answer?
So your answer is 6 pi over 7.
Okay.
So 5 pi over 14 and 6 pi over 7. Those are the complement versus the supplement. Make sure you know how to read your unit circle. Like the x is the sine and the y is the cosine. Yeah, there's really not too much else. Complements. I give you a bonus problem on here. There's 19 questions plus a bonus.
Wait, can we do another quick arc length one?
Sure. Yeah. You want another arc length?
Yeah.
Okay. Alright, I'll title that arc length again. So let's say I have a circle and the radius now is 6. And we'll do a big angle. So let's say this is 310 degrees and I want to find this length. I want to find this all the way around here. 310. Okay, how do I find that length? I start by finding the overall circumference. Okay, overall circumference would be 2 pi r. So that would be, yep, 2 pi times 6 or 12 pi. But I only want 310 degrees. I don't want the whole thing. So I take that guy times 310 over 360. And that comes out to be something, I don't know. Something less than 12 pi. $32. $32 exactly? 32.5 inches or whatever these units are in. Yep, 32.5 inches. Okay, good. All right. That's all. That should get you a good starting point. That was a lot of questions. Hold on just a second.